Hello, my name is Luke McNeil, and over the course of this past academic year, my teammates and I at Rose-Hulman Institute of Technology have been working on creating a self-interpreter and a graphical environment for that interpreter. We really enjoyed learning about self and diving into the deep end to get the interpreter working. First, I'll show some of our features of our interpreter and how we went about building the system. In another video, I'll explain a custom graphical interface we made that's modeled off the actual self interface. Um, so there's two ways to interact with our system. You can either uh, run it through a REPL, so that's just you type in some code and it tells you the result, or you can run it through the GUI. For this video, we're just going to be showing the REPL version just because it's simpler. Um, so as we talked about in our about the project on the GitHub page, one of our primary goals was we wanted a way to work with self that was easy. So in our experience, the best way we could find to actually get self running was to get a 32-bit virtual machine for Linux, uh, and then we could get it running. So that's not ideal, and we wanted people to be able to access it more easily. So because of that reason, we chose to make our interpreter with Python, which means anywhere you can run Python, you can run this self-interpreter. All right, so we're jumping into actually using the self-interpreter. So go over to the terminal. So all we have to do to start it is we just say Python on this file, which will start the REPL. So then it asks if we want to be in interpret or parse mode. For now, we'll just go to interpret mode. All right, so at startup, it's kind of building everything up. It takes a little while. All right, so now we're in our interpreter and we can do self things. So we can type 1 plus 2 and we get the expected answer of 3. But this video is kind of explaining how our interpreter comes to that answer. So the first step in figuring out how to do 1 plus 2 is figuring out what that actually means. So that means parsing this text into some thing that we can then interpret. So this is, we used a tool, Python LexInYak, which is based on the original LexInYak, which is parser generator. So it parses this code. We give it the grammar for self, and then it gives us an abstract syntax tree representing this code. So to build that, we modeled we used the grammar described here in the back of the self handbook, which kind of gives us syntax overview. So all of these rules, we have equivalent ones in our YAK file. All right, so then we have an abstract syntax tree representing this code. So then what do we do with it? So in our case, we're making an interpreter, so then we call an interpret function on that code, on that abstract syntax tree, and it gives us a result. So how does that interpret thing work? So at its most basic, it needs to know things like how do you do message lookup? So here it should be able to get the slot X out of this object and give us 1. So that includes implementing the very core features such as like message passing, parent lookup, things of that nature. So we got those things working. And then the next thing is you need some way to you need some primitive methods. So the first primitive method, or one of the first, is maybe int add. So here, uh, this is some primitive adding 1 and 3. So this will be parsed into an abstract syntax tree that knows it's a primitive procedure. And primitive procedures are special in that they just call a special Python code and do things with the 2 operands. So this will give us the answer 4. So now we can see how this original 1 plus 2 actually worked, in that it actually behind the scenes turned into a call to this int add primitive. But how did it know to turn into that int add primitive? So the place that we're actually getting plus from is in our system. So we have these basic primitives. We then build upon these basic primitives to build more complicated things. And that's called bootstrapping. So the way we did it in our system is and the real self does it, is it starts off blank and then it bootstraps itself up to have a bunch of these modules. So the way we built ArchSystem up is actually importing the filed out modules from self. So what these look like, I mean, so like the Boolean module has a bunch of methods defined for Booleans. The integer module has things like plus defined. And the plus, if you look in there, calls int add. So all of this, so that plus is actually coming from the fact that we were able to bootstrap up with the filed out versions of the modules from self. So this also means we get things like vector and other number stuff. So one example we could do is if we say get the factors of 45. So factors is some method defined in the number, in one of the number modules, I'm not sure which one. And then that gives us a list. If I want to convert that into a vector, so it prints nicely, we can call as vector, and then we get the factors of 45 to be 3, 3, and 5. So this is kind of a more complicated example of now we're using these methods defined in these modules that we imported. And the key point here is that we did not implement factors or as vector. Those all came for free as long as we get the basic primitives working that they rely on. The other thing that they rely on is that we get the bootstrap object working first, because all of these, to file in a module, it relies on that bootstrap module being in place. Okay, so now as an example, we'll show how we actually go about loading in one of these modules. So the reason this interpreter took a while to start up is because it was loading in all of these modules. So it was running code to load in all the functionality here. So we can actually like custom, after it's already booted up, we can load in another one. So here is one that I pulled. So the way I got this file is I went to self, I told it to file out the random module. It's almost the exact same, except one change is that it started with the seed being initialized to like a random time. Because we don't have time implemented yet, I just said to seed it at 1. So kind of cheating a little, but that just shows that there's kind of a hierarchy to things that you need to import first. All right, so if we want to import this self file, it lives in the directory. We got to go into self files, and then it's called random.self. So from our interpreter, we can say, here's a string called, and we'll give it the path to that file. And if we just run that, all it gives us is a string with that value. But then there's a primitive called run script. So what this does is it looks at the value of the string and tries to evaluate all the code in a file named that. So if we run that, it should load in the random stuff, and now we should have an object called random. And with how we print it, we can see all the slots. But one of the things you can do with random is you can ask for an integer between 1 and 10. You can see that it's random. So as we progress, we would want to move more and more of these filed out modules from self to be loaded in at the start of our interpreter. And we just get all of that functionality for free, basically, if we have the necessary primitives. So that's the overview. We really enjoyed working on the project, and we're really happy with how flexible it turned out and that we could load in the existing self modules. So we did also make a relatively simple graphical user interface that looks kind of like real self, but not exactly, as you can find in another video if you're interested on that. There is also a lot more work that we could do on this project. One thing is we can keep filing out these modules and keep importing them into our system. There's a whole bunch of them, not even close to having all of them. And one of those would be, some of those modules have to do with actually building up the GUI. So that would mean we could run all of the original self code to build up the GUI in our interpreter. That's not how we build our GUI now. it's just kind of a standalone custom thing. But in the future, if we get all of the many primitives necessary to make the GUI stuff work, we could theoretically import all the GUI modules, and then we'd have a GUI that looks exactly like the original self one. So that would be a very cool place to be. We're open to any feedback or questions. You can either reply to our post on the self-mailing list, or you can find our contact info on the GitHub repository. Anyway, thanks for listening.